In surgery areas where flammable anesthetics are used, specific electrical safety measures are crucial to minimize the risk of ignition. The installation of 240 volts, 50 amps receptacles for portable X-ray equipment necessitates a careful consideration of power source options. While the question suggests the possibility of using regular power if the receptacles are mounted above 5 feet, the correct approach is to feed these receptacles from a surgery area isolated power panel. An isolated power system is designed to prevent electrical shock hazards and minimize the risk of sparking in areas where flammable materials may be present. The fundamental principle behind an isolated power system is to eliminate any direct connection between the electrical supply and ground. This is achieved through the use of an isolation transformer, which isolates the secondary circuit from the primary power source and ground. In a standard grounded power system, a fault to ground can create a high current flow, potentially leading to sparks or electrical shock. However, in an isolated power system, a single fault to ground will not result in a dangerous current flow, as there is no complete circuit path back to the source. The National Electrical Code, or NEC, Article 517 addresses healthcare facilities and provides detailed requirements for electrical installations in patient care areas, including operating rooms and surgery suites. Section 517.63 specifically covers isolated power systems and outlines the conditions under which they are required. The NEC mandates the use of isolated power systems in anesthetizing locations, which are defined as areas where flammable anesthetics are used. The presence of flammable anesthetics creates a hazardous environment where even a small electrical spark can have catastrophic consequences. Therefore, the NEC requires the use of isolated power systems to minimize the risk of ignition. The isolated power panel provides several key safety features. Firstly, it incorporates a line isolation monitor, or LIM, which continuously monitors the impedance from each line of the isolated power system to ground. The LIM provides an alarm if the impedance falls below a certain threshold, indicating a potential ground fault. This allows healthcare personnel to identify and address any faults before they can pose a significant hazard. Secondly, the isolated power system reduces the potential for macroshock and microshock hazards. Macroshock refers to a large electrical current that can cause severe burns, cardiac arrests, or death. Microshock refers to a smaller electrical current that can be dangerous to patients with indwelling catheters or other conductive pathways to the heart. Because the isolated power system limits the ground current, it reduces the risk of both macroshock and microshock hazards. Thirdly, the isolated power system minimizes the risk of electrical interference with sensitive medical equipment. Electrical noise and interference can disrupt the operation of monitoring devices, infusion pumps, and other critical equipment. By isolating the power supply from ground, the isolated power system helps to reduce the level of electrical noise and interference, ensuring the reliable operation of medical equipment. Now consider the implications of using regular power for the X-ray receptacles. In a standard grounded power system, a fault to ground can create a high current flow, potentially leading to sparks or electrical shock. Even if the receptacles are mounted above 5 feet, a ground fault could still occur in the wiring or equipment connected to the receptacles. Furthermore, the presence of flammable anesthetics creates a highly combustible environment. The NEC Article 517.13 requires that all electrical equipment in hazardous locations be specifically approved for use in such environments. This typically involves the use of explosion-proof or intrinsically safe equipment. Using regular power receptacles in a hazardous location could violate the NEC and create a significant safety hazard. It's important to note that the 5-foot height mentioned in the question is not a determining factor in whether or not an isolated power system is required. The NEC mandates the use of isolated power systems in anesthetizing locations regardless of the height of the receptacles. The height requirement may apply to other aspects of electrical installations, such as the location of switches and receptacles in patient care areas, but it does not override the requirement for isolated power in hazardous locations. The decision to use an isolated power system is not simply a matter of convenience or cost. It is a critical safety measure that is required by the NEC to protect patients and healthcare personnel from electrical hazards. Failure to comply with the NEC could result in fines, legal liability, and, most importantly, injury or death. In addition to the NEC requirements, hospitals and other healthcare facilities may have their own internal policies and procedures regarding electrical safety. It is important to consult with the facility's engineering department and safety officer to ensure that all electrical installations comply with both the NEC and the facility's internal requirements. The installation of isolated power systems requires specialized knowledge and expertise. It is essential to use qualified electrical contractors who are familiar with the NEC and the specific requirements for healthcare facilities. The contractor should be able to properly size and install the isolation transformer, line isolation monitor, and other components of the isolated power system. Furthermore, the contractor should be able to verify the proper operation of the system and provide documentation to demonstrate compliance with the NEC. The NEC Article 517 provides detailed requirements for the testing and maintenance of isolated power systems. The LIM must be tested regularly to ensure that it is functioning properly. The isolation transformer should be inspected periodically for any signs of damage or wear. Any deficiencies should be corrected promptly to maintain the integrity of the isolated power system. The design and installation of isolated power systems can be complex and may require the involvement of a qualified electrical engineer. The engineer can help to determine the appropriate size and configuration of the system and ensure that it meets all applicable codes and standards. The engineer can also provide guidance on the selection of equipment and materials and oversee the installation process. In summary, the installation of 240 volts, 50 amps receptacles for portable X-ray equipment in a surgery area where flammable anesthetics are used requires the use of an isolated power panel. This is a critical safety measure that is mandated by the NEC to protect patients and healthcare personnel from electrical hazards. The isolated power system eliminates the direct connection between the electrical supply and ground, reducing the risk of electrical shock and sparking. It also incorporates a line isolation monitor that continuously monitors the impedance to ground, providing an early warning of potential ground faults. Using regular power for the X-ray receptacles is not permitted in this situation, even if the receptacles are mounted above 5 feet. The presence of flammable anesthetics creates a hazardous environment that requires the use of isolated power to minimize the risk of ignition. The NEC Article 517 provides detailed requirements for electrical installations in healthcare facilities, including the use of isolated power systems in anesthetizing locations. Compliance with the NEC is essential to ensure the safety of patients and healthcare personnel. It is also important to consult with the facility's engineering department and safety officer to ensure that all electrical installations comply with both the NEC and the facility's internal requirements. The installation of isolated power systems requires specialized knowledge and expertise. It is essential to use qualified electrical contractors who are familiar with the NEC and the specific requirements for healthcare facilities.